Good morning, guys. Today we have two master level problems for you. That means 2000 rated and another one is 2100 rated, as we hopefully can see. Yeah, around here. So both of these problems come from VK Cup. One of them comes from the final round and the other one from the qualifying. So I wanted to start with the 2000 one, which comes from the final. It's a very nice mathematically problem. I really like it. It's not quite master level, to be fair, but it's getting quite close. So not to overcomplicate the system of like how we divide tasks. I'll just go with expert, master, and grandmaster. In this problem, bottom tier reversals, we're given a permutation of odd lengths. We want to sort it. However, we can't do just arbitrary operations with this permutation. All we can do is select a prefix of an odd length and reverse it. Like here you can see what it means explicitly written down. We want to find a way to sort this array in at most 5 and over 2 operations, or say that no such way exists. One nice thing is that we don't have to minimize the number of such operations, probably because it's not clear how to minimize it at all. So there is a couple of test cases, but overall n is up to 2000 something-ish. So the way you are of course welcome to pause the video and think about this problem for a little while. I would not, I think that like 5 to 10 minutes is the maximum that you should think on your own. I think that you will either make good progress or just better to keep watching the video. Let's put it this way. So the way I was thinking about this problem was roughly as follows. And I want to share this thinking process, not only the solution, because I believe that this is what helps most in getting better. It's like understanding how some other people think about competitive programming problems and hopefully adopt some of their practices. So the first question I asked myself is when the answer is -1, that is when it's impossible to sort such an array. After playing with some smaller permutations, like of lengths 3 and 5, I realized that every operation allowed by the statement does not change the parity of the position of each element. So, for example, if we have an array of lengths 5, we perform a reversal on this subarray, then this element, it was on the 3rd position, it comes to the 1st position. That is, the parity of 3 and 1 is the same, so it has not changed. And obviously in the resultant array, I want all odd numbers to end up on odd positions. And I want all even numbers to end up on even positions, which immediately implies that, well, all odd numbers should start on odd positions and all even numbers should start on even positions. In general, if you have like, we can prove it more formally if you want, that it's hopefully not something difficult. If we reverse a prefix of length 2k plus 1, and we are looking at the element x that stands in position, let's say I, then position of x after the operation is 2k plus 1 plus 2 minus I. You can check it because like they reflect around the center. The pairs reflected around the center, they have the same sum of 2k plus 2. Therefore, if one of them is I, then the other one of them is 2k plus 2 minus I. You can check that by looking at endpoints. 1 plus 2k plus 1 is 2k plus 2. Here you find this sum. And you realize, well, okay, I and something is even, minus I, even minus I, they have the same parity clearly. If I is odd, then even minus I is also odd. If I is even, then even minus I is also even. That's how we arrived at this lemma. So hopefully this characterizes all permutations that are possible to sort. Like so far we only proved that all other permutation in which there is at least one odd element in an even position, or at least one even element in an odd position, these are not possible to sort in any number of operations. Where we still have two questions to answer. The first one is how quickly we can sort, whether we always fit within this limit. And the second one is this condition of every number being on the same on the position of the same parity as the number itself is sufficient for us to have a way to sort the array. It turns out that it is. Let me fix the light a bit. That was like my first step. I figured out it in approximately like 10 to 15 minutes. That should probably be not difficult once you think about once you have a general direction that you want to think in. Because here we have some configuration, some like array, and we are given some operations that change the configuration. It's quite often that in such problems, thinking about some invariant helps, and clearly the parity of the position of each element is an invariant, the most obvious one. So yeah, that's what I went with, and it worked. So think about invariants and problems where you're faced with a configuration that changes under some given operations. That is likely to help, like more than half of the time, I guess. Okay, but the next thing was like, where does this bound come from? Like, how we can? Is it actually a constraint, or is it something helpful? Around here, I realized that most probably, if a problem setter is an adequate person, which we believe Gennady Kurtkevich to be, then this bound is always achievable. Like if you can sort, then you can sort within the given number of operations. Or at least it would be really painful to discover that it's not always the case. So. But I just assumed for some time that it's possible, and I started to think about how we can potentially arrive at such a bound. It comes to mind in such things as like, which part of the permutation, can I sort like permutation in parts? So get rid of some parts, so say, okay, this is sorted, I'm no longer going to change it. After not long consideration, you realize that the only part that you can get rid of is some suffix of even length. Because if you sort some part in the middle of the permutation, then it's likely to get affected by the following reversals. It's not something you want to do. And here comes an idea of basic induction on n, or reduction, however you say it, if you name it. So I want to go from n to n minus 2. That is, I want to sort last two elements into their positions. And here I realized that this bound is actually a hint towards what you are expected to do, because it tells you that you are allowed 5 operations per each 2 elements. So that's like a strong hint towards some sort of induction. So now we have 5 operations per 2 elements. And then I just started to think about like how I can place 2 last elements into the last positions. But I assume that this is better. It's better to see in the implementation section, because like here effectively the mathematical part of the problem ends. You're faced with very simple problem of solving of sorting 2 elements into their position in 5 operations. You're likely to figure it out on your own if you just draw some pictures for maybe like 10-15 minutes. You're likely to figure it out on your own. That's probably why it's not quite master level, but still very, very close. So let's take a look at the implementation. Hopefully I can, yeah. Implementation is quite short, so we are like, first of all, we check if it's possible, or with what I already said, like the parity should, well, technically, because the indexes start from 0 and elements start from 1, the parity should be different, but implementation ditto. That means if the parity of 0-based index and 1-based element is the same, then something's wrong, we cannot sort it. So just have like quick look to check if that's the case. Otherwise, I defined a nice function reverse prefix that takes the position and first of all it like stores this reversal, and second of all it reverses my prefix. I find this way of writing code quite nice, because then you can call it 100 times, just supply a position. You don't have to care about remembering this +1 all the time or storing it somewhere all the time. And I say like, okay, I want to sort my permutation in pairs. Well, I like take 2 biggest numbers, and now I'm going to do some operations with odd and even. Also because of like how chilled the constraints are, they are like n up to 2000. You don't have to do anything quickly. You can just reverse the array. You can find position of each element by just like a for loop essentially. Or a call to find function, but that's like very chilled. Like the focus was to solve the problem and not on the implementation. Of course, you can perform reversals of subsegments faster. Pretty sure there is a data structure for that. I mean, obviously, keep track of all positions also. That's probably like just some another map. But that was not the point of the problem. The point was like, how do you sort 2 numbers in 5 operations? Here I started drawing pictures. I probably should, like, this is before the first operation, second, third, fourth, fifth. Right. Here I have 2 numbers. Let's say like red is the largest one, green is the second largest one. At the end I want something like this, right? So I started saying like, what's likely, like here I don't know what to do. Here I know very well how this happened. So this happens obviously by reversing the entire array, because there is no other way to affect the last 2 positions at all. And we have this, right? Once again, how this happened? Well, by reversing some prefix, right? So, like, the second element can't get here on its own, so it must have been some reversal. Let's say it's been around here. And this idea of thinking backwards is also quite common in mathematical problems. That's why, I mean, find it quite intuitive, but you may need some time to get a hold on it. Here it's now it's not that clear what I should do. I can reverse. I have two operations that I potentially can carry out. Something like this, reverse it, or something like this, reverse it. So I was not sure, but I noticed like in these three cases, both largest elements are together. So I start to think, how can I get them together? Actually, I would very like to get them together. How can I do that? And I noticed that, well, like, I want to put my red here, right? I can do that because that's a position of the right parity, but I can't do it in one operation. So essentially I thought like, okay, let me just put it here and then put it here, right? By reversing this part. Maybe I should highlight actually the part that we reverse. That's gonna help. So here I reverse that, here I reverse that. Here we reverse that, here we reverse that. But still have to get from like this. They are together now, but in the wrong order. What we should do? Well, we can just reverse the entire array because we don't exactly care which positions they are on. That step actually took me some time to figure out, like a couple of minutes, but eventually I got there. Technically, that's not all. That's not all, because your red body can start over here, or yeah, somewhere over here. But then you realize that, well, I can still reverse it and get into such position. This will be no longer at the same position, but it will be just somewhere, right? So, like in terms of who is on which side and who is in the beginning, or if they are together, this changes nothing if it starts on the right side. So I have just one generic implementation. Works as follows. So first we reverse the prefix that ends at the position of odd element, that is at the position of red. And I reverse this to get red close to green. Then I reverse this entire thing to get this. Then I reverse position of odd, that is this. And I reverse the entire array. Technically, even is like the length of the array -1. You could also write odd -1 here. I just saw like what's the length of the array. That is what's the last index. That is even. So that's what happened here. This is not a position of the greenish element. It is legit the length of the array. Excuse me, let me take a second. Yeah, it's hard talking to a camera for a long time, but whatever. And then we just print the answer, so like fairly simple. Very nice problem. I really enjoyed this mathematical way of thinking, like somewhere you have to figure out invariant, somewhere you have to like go backwards to figure some operations, then do something else. You don't care about how efficient your implementation is, you just perform linear operations at most linear number of times, so like your complexity is quadratic, but n is up to 2000, so that's fine. Very short problem. I really liked solving it. I encourage you to try to implement this approach yourself. That will likely help you further up the road. The second problem that I want to discuss comes from a qualifying or elimination route. It's problem E and it's 21 hard rated. It asks you, it checks your understanding of prefix function. Like quite often people just use prefix function without actually understanding how it's computed, or like or just without understanding like the full set of its capabilities. There's probably given a string and we can reorder it arbitrarily. We want to minimize the maximum value of a prefix function. So a prefix function is an array, of course, and it has some maximum element somewhere. We want to minimize that maximum element. However, we want to minimize them in such a way that we want to output specific string that minimizes that function f, and that is the lexicographically smallest string t. T is quite long, but that's not a real problem here. So that is a problem. You can think about it if you have a good understanding of prefix function, or just read the definition, and you may be able to make a good progress on it, because like this problem is quite good because it does not test your how many data structures you have pre-written. It tests like how well you can think about the concepts that you already know. You just need to apply them in a new setting. That is like pure algorithms. So really great problems from Gennady this time. And I imagine that it only gets better when you take like not problem E, but let's say G or something. So yeah, but I'll start sharing my approach to this problem. I did not check the editorial, so there may be different approaches, but let's hope that my approach is not terrible, because I don't think that it's terrible. It has some casework, but that's like acceptable amount of casework. As first things first, I realized that what we really want to do is we want to construct a string in such a way that its prefix is like, it does not appear too often in the other parts of the string. And first thing I realized is that, well, if I have a character A, that like the smallest possible prefix is one character. Without loss of generality, we can assume that this character is A. And if I ever get another character A in my string ever again, then my prefix function is at least 1. Not ideal. So the first idea that I got is, well, like if I have a unique character, then I can just bash it in first, and then whatever I put next, no prefix will ever coincide with no suffix, because like no suffix ends at the same character. So that's my first case that I consider is like, if we have a unique character, let us just put the lexicographically smallest unique character first, and then we are set. The rest of the things we just have to sort lexicographically, and then we are done. So that is actually what the first sample is about. I did not read the sample properly before arriving at this conclusion, but like it did not take me much time either way, so whatever. And I actually, the second thing I realized is I actually look at the samples and I realized, well, if all characters are like the same, then there is not much we can rearrange, so we can just print the same string. So now I simplified the problem a bit. So because I already considered a case when I do have a unique character. So now I need to consider the case where I do not have any character, but at the same time I have at least two different characters. So I thought that should have something to do with frequency array. So we have at least two characters, let's call them A and B. They have some frequencies. Frequencies are at least 2. So at this moment I was like, okay, I cannot get value of 0, so I should aim at value of 1. I'm obviously getting a value of at least 1, so what I actually have to prevent is value 2. So I want to construct a prefix of length 2 that will not occur anywhere in the string ever again. So I start to think like, okay, what's the smallest I can do? AA, right? Now the only thing I have to avoid is ever having AA again in my string. So I started to think like, what happens if I do something like this? I realized that if A is not too often, like for such a string, if I take B something A something A something A, for like if I ran out of other characters before I ran out of A, and it means that A is very common. It has like at least half of the entire length, maybe a little bit more. So like in case the first character is not too common, we can do something like this. That if these characters come in lexicographic order, this will be optimal. Yeah. So now I have to consider a case where A is way too often. Start to think, well, I already checked if I can make AA my prefix of length 2. It appears that I can't. So let me start with AB. How do I prevent prefix? Like, how do I prevent AB from ever forming again in my string? If I was about to like just sort the rest lexicographically, I would end up with something like this, which has a B in it. So not ID. So what I was thinking about, let me just take whatever is the third smallest character, let's say C, and bash it in here. Then that's all good. So you had one place where it could go wrong, and we fixed it. It's lexicographically minimal. So if I have one very common character A, but I have at least 3 characters A, B, C, then I'm able to like make this kind of situation and just fix it a little bit afterwards. And then I said, okay, so my only problem now is like I have 2 characters, and one of them is they are not too balanced. If they are balanced, then you can do something like this. If they're not very well balanced, then you have to think like. Here I realize that's like no matter what I place, if I place any A before any B by discrete continua, how do they call it? You know, in Russian they say дискретная непрерывность, but how do you say that in like in English? Okay, I don't actually know, but like if any value of A comes before any value of B, then obviously there is an AB somewhere. So what I realized is, well, I made one run submission because I tried the dumb way of fixing this situation. The smart way is, of course, just do this. So place all your letters B before your letters A, then you don't have AB ever again in your string. That's more or less how I got accepted. So there is not much to this problem. It's just like understanding the concept. You know, just some casework, but very reasonable casework. I think that partially why this problem is 2100 rated is because problem D2 was quite complicated. Oh no, that is a different D. Okay, then I have no idea why this was 21 heart rated. As we can see, like some master level problems are quite easy. So just believe in yourself. I guess don't give up unless you want to. Sometimes you just need to like do some casework and it will turn out just fine. You can see I actually left comments like only have one. F is frequency map. MP is like which character is first, second, etc. If I have cases like if I have only one character, if there is a character with frequency 1, if all characters have frequency, otherwise all characters have frequency at least 1, then I make 2 checks like if if first letter is not too common, then I can start with AA, otherwise I can't. Here if I have at least 3 different characters, I can start with AB quite easily. Otherwise, I can start with AB in a non-obvious manner, as it is, because I made the wrong submission once. Only this part differed. Like I had a different idea where we were starting with like BA instead, which was never going to work. But like hopefully, luckily, I discovered this quite quickly, in like only 10 minutes or something, that I can actually do this, and it will be lexicographically smaller. Very nice problem. Once again, we talked about like either Monday this week or last week, but always look at bounding your answer. So in this problem, like answer is always 0 or 1. Answer in terms of like minimum value of function f that you can achieve. If you see that it's bounded, then it's likely that there is a some sample construction that achieves this bounded value. That was another thing that helped me. Like I realized that it's quite easy to get a unique prefix that does not appear further up the string. So I was pretty sure that the answer, like the maximum value of f will be 0, 1, maybe 2, but most likely 0 or 1. So it helped me greatly in having confidence to just get through this casework, knowing that I'm very likely to succeed. Because it's like there must be some way of building a unique prefix that does not appear further down the string. I just had to figure it out for all cases separately. So yeah, the point of today's video is some master level problems are quite easy. They require you to think for a little bit, but they don't necessarily require you some crazy implementation, some data structures. That's not needed to get to like candidate master or master level, honestly. Sometimes I feel dumb about being only a master, because when I see such problems, because I realize, well, like I should be solving something harder, you know, like because that's not really not that difficult. So hopefully you kind of got some ideas from me, like how to think about the problems to successfully solve them. I think that's all I wanted to share with you today. Tomorrow we'll be back with 2 more master level problems, but like they're a little bit harder, like 2200 rated and 2300 rated. Maybe those will require some data structures or something like that, I don't know. So yeah, but that's all I wanted to share with you today. I hope you learned something new. I hope you learned how to think about problems. And with that in mind, I'll see you tomorrow with more problems. Bye bye, guys.